Hello guys, welcome back to my channel. In today's video, we are going to discuss about the type and working principle of single phase induction motor. The induction motor works on the principle of electromagnetic induction. It defines that the electromagnetic induction is the creation of EMF due to moving magnetic field around the conductor. Depending upon the methods of producing stator magnetic field, the single phase induction motor types are classified as split phase induction motor, capacitor start induction motor, capacitor start run induction motor, shaded pole induction motor. The single phase induction motors are not self-starting due to the alternating flux acting on the squirrel cage rotor cannot produce rotation, can only produce revolving flux. The possible way to make the single phase motor self-starting by converting the single phase supply to two-phase supply by adding the additional winding, that is nothing but the auxiliary winding or starting winding. The auxiliary winding is placed 90 degrees apart from the main winding. Let us discuss about the split phase induction motor. This motor has a single phase main winding and an auxiliary winding that carries a series resistance. The impedance of auxiliary winding is resistive in nature, whereas the main winding is inductive in nature. The auxiliary winding has a centrifugal switch connected in series with it. When the motor attains up to 80% of its synchronous speed, the centrifugal switch gets opened. The auxiliary winding is designed for short time use and the main winding is designed for continuous use. From the above phasor diagram, the current Im and Ist splitted from each other. Thus the motor is commonly called a split phase motor. These motors have moderate starting torque and less starting current. It is used for easily started loads like burners, blowers, washing machines, etc. Capacitor start induction motor. Construction of this motor is same as that of split phase type. The difference is that in series with auxiliary winding, the capacitor is connected. Depending upon whether capacitor remains in the circuit with connectivity or disconnected from the circuit, these motors are classified as capacitor start motor and capacitor start run motor. When the speed attains 75% to 80% of the synchronous speed, the auxiliary winding gets disconnected by means of centrifugal switch. The capacitor remains in the circuit for starting purpose alone is called capacitor start motors. The capacitor start induction motor are employed wherever the high starting torque is required. The good examples are conveyor, compressors, grinders, etc. For a practical example, here I have taken a capacitor start induction motor which is used in wet grinders. These motors usually have 8 microfarad capacitor for starting purpose alone. Let's test. As you can see, the motor just creates a humming noise, but it couldn't spin. Now let's connect the capacitor. That's all. Whenever the motor attains 75 to 80% of its synchronous speed, the auxiliary winding will get disconnected. Even though the capacitor remains in the circuit, it's only for starting purpose alone. In capacitor start run motor, there is no centrifugal switch and the capacitor permanently remains in the circuit. This improves the power factor. The direction of rotation on both sides can be achieved by interchanging the connections of main winding or auxiliary winding. These motors are expensive when compared to split phase type motors. These motors are used in ceiling fans, blowers, air circulators, etc. As a practical example, here I have taken a ceiling fan connected to the power supply without capacitor. These motors require capacitor to activate both functions of starting and running. Sometimes this motor can spin due to mechanical effects, but it won't have enough amount of torque to handle the loads and the speed will not be sufficient. Hence, capacitor is must for this motor to start and run. Shaded pole induction motor. These motors consist of squirrel cage rotor and its stator consists of salient or projecting pole. When a single phase AC supply is given, A rotating magnetic field is generated in it due to shading. Direction of rotation is from unshaded to shaded part of the pole. Hence, the phase angle between shaded and unshaded portion is very small. Shaded pole motor produce only less torque and has very low starting torque, low power factor and less efficiency. These motors are commonly used in small fans, toy equipment and DVD player, etc. For a practical observation, I have taken a shaded pole induction motor out from a small electric fan. The windings are completely burnt. Let me dismantle and show you the motor. Shaded and unshaded portions of the pole, those windings that you can see on both sides, that is nothing but shading coil. A squirrel cage rotor, and it is supported by bush on both the sides. That's all for today. Hope you guys enjoyed the video. Don't forget to like, share and subscribe my channel for more interesting videos. Thanks for watching.